Welcome to tutorial 5 for advanced output for a single image. In this tutorial we'll be demonstrating a new functionality that is added to a ctFIRE control panel for post-processing the extracted data from ctFIRE. This functionality requires that the ctFIRE has already been run on a particular image, as well as the width, angle, straightness and the length data is already saved in Excel files using angle histogram and values, length histogram and values, straightness and width options while running the ctFIRE. We can check that whether these files are present by opening the directory in which the image is present. Open up ctFIRE out, a .mat file with the format of ctFIRE out underscore file name, and the angle, length, straightness and width Excel files for the particular image. Test image 1 in this case should be present in the ctFIRE output folder. To launch the post-processing graphical user interface, click on out.adv, leave the batch and the .mat checkboxes unchecked, click on post-processing. A new window opens up with the title Analysis Module. Since we are using the advanced output features for a particular image, for a single image, therefore we leave the batch mode and the stack mode checkboxes of the analysis module unchecked. Click on select file. In this tutorial we'll be using test image 1 as an example, so select test image 1. We see that two images open up for the particular selected file. One is the original image and the another is the original image with the overlaid fibers. Notice that each fiber is assigned an index. The details of the fibers can be seen by zooming in by selecting this tool from the toolbox in the figure. So the other functionalities in this post-processing graphical user interface is visualize fibers. This option allows the user to see only specific fibers overlaid on the original image. If there are multiple number of fibers whose geometry is not very clear, then the user can select the number of the index of each fiber he wants to visualize. To use this functionality, click on visualize fibers. This opens up a small window in which you have to punch in the numbers corresponding to the indices of the fibers the user wants to visualize. Let's visualize fiber number 228, 258, 220. Punch in the numbers 228, 858, 224 and 237. Click on OK. This opens up two windows. One window shows only the fibers whose numbers were punched and overlaid on the original image. This functionality allows the user to see that whether these fibers, to decide that whether particular fibers are false negative or false positive. If the user thinks that these fibers are false negative or false positive, then these fibers can be excluded from further analysis, the details of which we'll be showing shortly. Another window that opens up is the window titled Selected Fibers. It shows 5 columns. One column is for the corresponding index of the fiber, and the other is width, length, angle, and straightness. The values are corresponding to each fiber. This process can be done iteratively, that is, the fibers can be visualized n number of times to give the user an idea that which fibers does he want to use in analysis. Like this time we'll visualize fiber number 54, 55 and 69. So 2 more windows open up. Another functionality is removing certain fibers from analysis. Click on Remove Fibers. Suppose I think these fiber numbers 228 and 258 are false positives, and I don't want to include these fibers in my analysis. Then I'll punch in the numbers in this window and click OK. A new image opens up in which all the fibers are present except the fibers whose indices were mentioned in Remove Fiber window. In order to remember the fibers which we deleted from analysis, look at the status bar of Analysis module window. It mentions the fibers that have been removed so far. This process can be done iteratively, like we'll do one more time. If the fiber numbers are not clear, you can always magnify and see which fibers do you want to remove. For example, in this case I'll be removing fiber number 307. Punch in the number 307 and click OK. Similar thing happens, that is, a new image opens up without the fiber which we selected for removal. After the user is satisfied by the removal of the fibers, click on Save Fibers. After this is done, the user cannot revert back. If the user wants to remove fibers even now, then he'll have to reset the analysis module using this button. Moving on, a new window opens up when we select Save Fibers, which shows only the fibers that would be used for analysis. Note that the indices are no longer present for this image, so as to increase the clarity of fibers. Next, the user can threshold the fibers based on certain properties. For example, if the user is interested in only visualizing the fibers whose length is in between, say, 50 to 100 pixels, or if the user wants to visualize only the fibers with length in the top 20%, then this can be done using the post-processing graphical user interface titled Analysis module. If thresholding is desired, click on the checkbox. There are 2 options for specifying the thresholds. One is the percentage and another is the absolute values. Note that in the beginning the default values are mentioned for the thresholding. When I select percentage, it shows 0 and 100%. When I select absolute values, then it shows 30.1 and 460 point something for the test image 1. These are the minimum and the maximum value of the length of fibers present in this image. Similarly for width, straightness and angle. In the current tutorial, we'll be using percentages. In the current tutorial we'll be using percentages for thresholding the fibers. Select on percentage. For the properties for which the conditions need to be specified, for example, if we want to specify the thresholds for length, click on the radio button next to length. This enables two text boxes. In this tutorial we'll be using 20 and 70. Similarly for width, 20 and 70. Note that if multiple thresholds are selected, then only the fibers which satisfy all the specified conditions will be used for analysis. In this example, only the fibers which lie between 20 to 70% of the maximum length and the fibers with the 20 to 70% of the fibers by increasing order of width will be selected for analysis. Click on threshold now. This opens up a new image with only the fibers that satisfy both these properties. This process can be done iteratively, that is, the user can change the thresholds since the threshold values have been changed. The fibers that are displayed are different. Once the user decides on a particular value, then click on Save Fibers. This displays the fibers that will be used for analysis further. The last part of the post-processing graphical user interface is generating the data in the form of Excel sheets. Click on Generate Stats after you decide on which stats, on which properties for which you want the statistics for. The default values are the statistics will be generated for all the properties, that is length, width, straightness and angle. Click on Generate Stats and you can select or deselect the properties, the output statistics which you want for each property. The default values are all the output statistics are selected. Click on OK. The status bar shows that whether the statistics have been generated or they are in the process. Currently the statistics have been generated. In order to view the statistics, open up the folder containing the image. So the statistics are saved in a folder called Select Out in the directory containing the image. For the image, there are two sheets that are created. One is the statistics sheet, which shows all the output statistics for the properties of width, length, angle and straightness. Notice that alignment is only shown for angle because alignment is calculated based on the angle of each fibers. The another sheet is the selected fibers. It shows all the fibers and the properties which satisfied the thresholds that were mentioned in the post-processing graphical user interface. Also, there is an image saved in the folder Select Out, which shows the fibers that were selected for analysis while doing the post-processing for the particular image. Thanks for watching tutorial 5.